The next step in our future value, present value process is trying to figure out what happens over the course of more than 1 year. Okay, so we've already looked at the fact that the future value of some equation is equal to the present value times 1 plus r. Okay, so let's go back to our other example, and let's say what happens. We have a $100 investment at 5%, which is going to be 1 plus 0.05, and we know that that's going to equal to $105. And so this $100 represents your initial investment, and this 105 represents what you have at the end of the 5 years. As we know, we could take that 105 and deposit it for another second year, which would turn that into 1 plus 0.05, which would turn that into, let me bring up my calculator, 105 times 1.05, which equals 110.25, which would turn that into 110.25 cents. But an easy question for us to ask is it possible to calculate both the first year and the second year at the same time? And here what we're going to do is we're going to create a substitution effect. This 105 is obviously the same as this 105. So what we're going to do is we're going to substitute this entire, let me do this with a different color. We're going to substitute this entire thing here into this 105 here. So what does that look like now? That looks like $100 initial investment times 1 plus 0.05, which substitutes here, and I still have this 1 plus 0.05, and all of that equals to 110.25. Now this isn't much different. Let me push that up just a little bit more. But this is easy. We can simplify this a little bit more into 100 times 1 plus 0.05 to the second here, right? Because I'm just squaring these two. These are the same, so I just square it. And that still equals to 110.25. If I turn around and let 2 equal the total number of periods, then I can come back and I can take a look at this again as if it were an algebraic equation. My present value, 100, is equal to 1 plus I, my interest rate, to the n, which is the total. N is equal to the number of periods. Up here it was 2, 1, 2, which is why this is squared. And now I'm going to substitute as n, and that equals to my future value. So if we were to calculate an equation, say I were to tell you what would happen to $400 today, remember our cheat sheet, present value is equal to I is equal to, say I deposited at 7% per year, and n, I left it in for 8 years, then what would be my future value? Here, if I plug this into the equation, it would be 400 present value, 1 plus I, 1 plus 0.07 to the 8. And what is that? I don't know. Let's calculate it out. Whoops. I don't know. Let's calculate it out. So this would be the same as saying 400 times 1.07 to the 8, which, if I bring my calculator back, clear. I don't know how to clear. 1.07, 1.07. I'm going to x to the y, or y to the x. Your calculator may say y to the x, but I'm going to x to the y. And then I'm going to hit 8, because 8 represents this 8 here, equals 1.718. So this is 400 times 1. Where did my calculator go? 1.718. 1.718 is equal to, I don't know. And then I got to figure out a better way to do the calculator. 1.718 times my 400 equals 687.27. So this is 687.27. And if we go back and look at this future value equation, it's the same thing as we've always done. Present value times 1 plus I to the n is equal to future value, and that's all we did to calculate this right here.